Hello everyone. So let's solve previous year GATE 2007 question based on CPU scheduling algorithm, and there are given four processes P1, P2, P3 and P4 along with their execution time and arrival time, and we have to apply shortest remaining time first algorithm, and we need to find out what we need to find out is the total waiting time of the process P2. Now let's solve the question without any delay. So here if we talk about this algorithm, SRT algorithm, the process which has the shortest remaining time, burst time, is going to take the CPU. Fine. So if I consider this, the processes that are given here, we have to consider both the execution time as well as the arrival time. Now P1 execution time is 20 and its arrival time is 0. And P3 has execution time 10 and arrival time 13. Now see, though the burst time of P3 is lesser than P1, but still P1 will continue in the CPU because the arrival time of it is 0, and this P3 process is going to arrive the CPU after 30th millisecond. So we will later on see whether this will be preempting which process into the CPU. So P1 is going to execute for next 15 millisecond. After 15 millisecond, P2 will join the ready queue, and we will see out of P1 and P2 whichever is having least burst time. That process is going to overtake the previous process. Now let's see. So initially, if we can see at the 0th millisecond, we have only one process, that is P1, and that P1 is going to take the CPU and it is going to run for next 15 milliseconds. So it has completed 15 milliseconds of time and it is left with 5 milliseconds of burst time. Now at this particular time, earlier P1 was already there. Now P1 is there, but P2 has also joined. The remaining time of P1 is now 5 and P2 is 25, out of which P1 is minimum. So P1 will continue into the CPU for next 5 milliseconds. So 15 plus 2 is 15 plus 5 is 20. So here P1 has completed its execution, and P1 completed its execution first. After that, at this 20th millisecond, we have only one process in the memory in the CPU, that is which one? That is P2. Because P1 is complete now and P3 and P4 will join later on. So P3 will join at 30th millisecond. So this P2 is going to run for next 10 milliseconds. So P2 is going to run for next 10 millisecond, 20 plus 10, that is 30. So the remaining burst time of this is 25 minus 10, that is 15. Now at this 30th millisecond, who has joined the system? P3 has joined at 30th millisecond. So we write here that P2 was already there and P3 has also joined. So remaining time of P2 is now 15 and P3 is 10, right? So who is going to join? Who is going to take the CPU now? Out of both of them, just think of it. Who is going to take the CPU? P2 or P3? So P3 is going to take the CPU because the remaining burst time of P3 is less, that is 10. So who will overtake this P3 is now going to preempt P2 and P3 will join the CPU, and it is going to run for next 10 milliseconds. 30 plus 10, that is 40. And we can see that this process P3 has also completed its execution. The next process which has completed its execution is P3. Now at this 40th millisecond, who is there in the system? We have only one process, and that process is P2, because P4 will join at 45th millisecond. So this process P2 is going to run for next 5 milliseconds, and later on we will decide who is going to be there in the CPU. So P2 is again going to be into the CPU and it is going to run for next 5 milliseconds. Right? So 40 to 45 is also P2. Now again P2 is, so how much time is being remaining in this P2? So if we talk about this P2, 5 has also already executed, so we are left with only 10. So still P2 is there, and along with that P4 has also joined. Remaining time of P2 is 10 and P4 is 15, out of which is smaller? P2 is smaller. So P2 is again going to still there in the CPU only. So here P2 will be there and it is going to run for next 5 milliseconds, not next 10 milliseconds. So 45 plus 10 is 55. And then finally, at this 55th millisecond, we only have P4 with us, and P4 is going to execute for next 15 milliseconds, right? So it is 55 plus 15, that is 70. Now let's see the question. What we need to find out? We need to find out the total waiting time of process P2. So let's find it out. So waiting time of P2. What is that? If you can see from here, P2 completed, let's see here, P2 waited for 40 milliseconds, right? So from here to here, P2 waited for 40 milliseconds. But if you can see, P2 was running in this during this period 20 to 30. It was executing. It was not waiting, but it was, this is the execution time, not the waiting time. So we are going to subtract this 40 minus 10, right? And after this, we will also subtract the arrival time. So what is the arrival time of P2? Arrival time of P2 is 15. So we are also going to subtract this 15 from this. So now the remaining time is 40 minus 25. That is 15 milliseconds. So this is the right answer. Now let's see the different options. So we are having 5, 15, 40 and 55. So the answer is 40. The answer is 15 milliseconds. So I hope you understood the concept and it is very clear how we obtain the things. We have to do the numericals on CPU scheduling. So to learn more, stay tuned to my channel. Thank you so much.